Hey guys, I want to go ahead and talk about the mean value theorem just real quick. Just like the theorem says, mean value. Remember in I think it was geometry where you learn about mean, median, and mode. What is the mean? Well, what does that mean? The mean is basically the average. Average. Well, how do you figure out the average of something? You add them all up and divide by whatever it is, the amount, right? Well, the mean value theorem is kind of like that. It'll make sense why they call it the mean value theorem. But we have two types, basically the one for the derivatives and the one for the integrals, and they're both related, just as derivatives are related to integrals. Now, basically, the mean value theorem says that this f prime, okay, which we call the instantaneous rate of change, is equal to the average rate of change. And some people call it IROC and AROC, average rate of change. Now, it makes sense because what does the mean? It's the average. Okay. Now, what this is telling you, all right, let's say we have a function here, okay, from A to B, okay, right here. It's telling you that the average, okay, if we're taking a road trip here, we're going to have different miles per hour, different speeds. But if we go from beginning to end and we just average out the time, all right, we're going to get a certain value, all right? We're going to get a certain value from here to here. And that's just y2 minus y1 divided by, x2 minus x1. All right, so these are my x values here. You can think about it like that. My y values. So basically, I'm calculating the average slope here, and what it's telling me that the average slope is equal to the instantaneous. So if I'm driving, let's say I take a road trip here, okay, there's at least one point, one value, we call it C, where the instantaneous rate of change, the instant, okay, the derivative, the instantaneous rate of change is equal to the average slope. Okay, so let's say you're taking a trip and you're driving, you drive 80, 90, then you drive 60, and then you speed it up. Well, let's say your average is 60 miles an hour. Okay, this line here represents 60 miles an hour. Okay, well, there's at least one point, there's at least one time during the whole trip where you hit exactly 60 miles per hour. You had to, because that was your average. Okay, so that's all it's telling you. Now remember, there's a couple of things you need to remember. In order for this to work, the function must be continuous on the interval, on the closed interval, and it must be differentiable. Well, you guys know what continuous means. Differentiable, of course, means you have to be able to take the derivative. All right, and those are key. And that's all it means. So it means that the average slope is equal to the instantaneous slope. There's at least one value, one C value where that's true. Okay? And then we'll do an example. For the integrals, okay, this one, you'll always hear this word here, this statement, find the average value. Average value. Okay? And that's a takeaway, that you have this relationship here, okay? And if you notice, it's the 1 divided by b minus a times the integral from a to b of f of x dx. Well, if you take the integral of f of x dx from a to b, you're going to get f of b minus f of a, which is technically this guy right here, right? The antiderivative. Okay, well then what b minus a, it's on the denominator. Well, look at here, it's right here. So these two are actually related. The only difference is this is dealing with derivatives, this is dealing with integrals. So what happens is they give you a certain function and pretend, remember when we talk about integrals, is the area under the curve. So let's think about this function here, like there's water here underneath, right? And it just kind of all over the place. But what happens if we kind of just let the water fall down and make a nice neat rectangle, all right, that we can calculate the area? And when we kind of level everything out, there's actually an average value here in the middle where it's calculated. So think about this as liquid, and all of a sudden it falls down, and we can calculate the average here of what's underneath the curve, and that's all it is. And we'll go ahead and do an example of that. And all of this is just kind of taking an integral. All right, and we'll kind of make the application. So let's go ahead and do one here. And if you notice, it says find the average value of f of x over the closed interval from 2 to 4. And this is my key term here, the average value. So what I'm going to go ahead and do, I already know, 1 over b minus a, the integral from a to b of f of x dx. So was that pretty much means from 2 to 4. So I'm going to go ahead and do 4 minus 2. Remember a and b. So we're going to go ahead and do 4 minus 2. The integral from 2 to 4. F of x dx, well, that's my x cubed dx. Okay. 4 minus 2, well, that's 1/2. Okay. Times the integral. And x cubed, well, you're going to go ahead and integrate that. Let me go ahead and just write it right here. X cubed dx. Now it's just a matter of going and doing the math here. So x cubed becomes x to the 4th divided, remember, by 4. From what? From 2 to 4. Okay. And what happens there? Well, you plug in the 4 to the 4th divided by 4. Okay. Minus, so it's top, minus the bottom. And you plug in the 2 to the 4th divided by 4. All right. So this is technically 4 minus 1. Remember, kind of like the rules for exponents. So that becomes 4 cubed minus, and this becomes, what's that? 16 divided by 4 is 4. So now you have 64 minus 4. 64 minus 4 is 60. Okay, now that's the integral, but remember there's 1/2 in front of it. Okay, so this becomes 1/2 of 60. Okay, which becomes 30. So what does that mean? That means that the average value, okay, underneath the curve of x cubed between these two points, these two values here from 2 to 4, okay, of this function here, x cubed, the area underneath the curve, the average value of that area is 30 units. That's what that's telling us, okay, when we average it out, when we make it nice and level. All right, and that's all it's telling us. So basically it comes down to taking the integral and then just tacking on that b minus a in the denominator here. All right, and remember, you're always going to see this wording here, average value. All right, let's go ahead and do another one here. Find the value of c which satisfies the mean value theorem. And find the value of c, so now I know they're talking about taking the derivative. So let's go ahead and do that. So it's telling me basically f prime of c is going to equal to the average f of b minus f of a divided by b minus a. Okay, so what's the derivative? Well, the derivative of this guy, well, it's going to be f prime of c. I'm just going to go ahead and use c instead of x. So that's going to give me 4c plus 16. And that's it. Okay. So then I have 4c plus 16 is equal to, now f of b, remember a and b, so f of 4. I got to figure out f of 4. Okay. So f of 4, and maybe I should just go ahead and write it here, f of 4 minus f of 2 divided by 4 minus 2. Okay. So what's f of 4? Well, I got to figure it out. F of 4, plug in here 2, 4 plus 16 times 4 plus 2. And when you do that, okay, you're going to get 16 times 2 is 32. 16 times 4, that's 64 plus 2. So that's going to give you, what is that? 96 plus 2 should give you 98. So you have 4c plus 16 equals 98. Minus, now I go ahead and do the same thing with f of 2. Now, f of 2, I'm running out of room here. Let's go ahead and do it up here, f of 2. F of 2, let's go plug in the 2. The 16 times 2 plus 2. Okay. So that becomes 2 squared is 4. 4 times 2 is 8. 8 plus 32 is 40. 40 plus 2, this should give you 42. Alright. So now I have this relationship here. So let's go ahead and do 4c plus 16. 98 take away 42. What is that? Let's see. 8 minus 2 is 6. 9 minus 4 is 5. 56 divided by 2. Alright, so let's keep going. Half of 56 is 28. So now we have 4c plus 16 is equal to 28. And now I have that equation, that relationship there. So when I go ahead and do this, let's see here. I should get 4c is equal to, what is that, 12? Therefore, c is equal to 3. So there's a value c. When c is equal to 3, okay, that tells me the instantaneous rate of change is equal to the average rate of change. And that's all it tells me. Alright guys, so I know that was kind of tedious and long, kind of, especially with these polynomials. Now, polynomials, guys, you have to understand they're always continuous, and so that makes it easier. Let's take a look at another example. Let's take a look at number 3 here. Now it tells us the same thing. Find the value of c of this function between the interval of -2 and 1. There's a problem though. X cannot be equal to what? 0. Okay. Why? Because we can't divide by 0, it'd be undefined. This is a rational function. You notice it'll have a vertical asymptote at x equals 0. You look at here, between -2 and 1. 0 is right in between there. So what does that mean? Okay, the mean value theorem does not apply. Okay, there is no c. I can't use it. The mean value theorem does not apply because why? This guy is not continuous. How do you know? Well, this is a rational function. And between -2 and 1, look at x cannot equal to 0. 0 is right in between this domain. Well, how about this guy right here? Pretty much same thing. Okay. If you notice, x cannot be equal to 4. Well, why? Because if we go ahead and take the derivative of this guy and we try it, we're going to get 2/3 times x minus 4. Now 2/3 take away 1, that becomes -1/3. Well, that -1/3 becomes important because remember, negative exponents makes it do the reciprocal, so that guy's going to be on the bottom. It's going to look like that. Now, remember, x can be equal to 4 because now this guy's in the denominator. So what happens? Look at 4 is between 2 and 6. X can be equal to 4. So what does that mean? Therefore, mean value theorem does not apply. It just does not apply. Okay, so sometimes you just gotta kind of have to think about it. A lot of times in the AP exam, they'll give you polynomial functions, something that's very easy and direct. Maybe a trig function like sine, cosine, or e to the x. But hopefully that helps, guys, and keep working hard.